exploring the power of static electricity with a balloon and paper objective. In this experiment, we'll learn about static electricity, how it is generated, and how it can attract small objects like paper pieces. We will see the invisible force of static electricity in action using simple everyday items. Materials needed: a balloon, preferably a latex balloon, small pieces of paper cut into confetti-sized bits, a woolen cloth or your hair, a smooth surface like a table. A dry environment: static works best when the air is dry. Procedure: 1. Prepare your setup. Spread the small paper pieces evenly on a flat surface, such as a table. Make sure they are light enough to be easily attracted by static electricity. 2. Inflate the balloon. Blow up the balloon to a medium size and tie the end so it doesn't lose air. 3. Charge the balloon. Rub the balloon vigorously against the woolen cloth or your hair for about 20 to 30 seconds. You will feel the balloon getting a little warm. This rubbing transfers electrons and builds up static charge on the balloon surface. 4. Test the static charge. Slowly bring the rubbed balloon close to the small pieces of paper without touching them. Observe what happens. 5. Experiment. Further, try moving the balloon closer and farther from the paper pieces and notice the changes. Rub the balloon again if the attraction weakens. Try rubbing the balloon on different materials and see which gives the best effect. Optionally, bring the balloon close to your hair or a wall and observe any reactions. Scientific explanation. When you rub the balloon against wool or hair, electrons transfer from one surface to another. This process is called triboelectric charging. The balloon gains extra electrons and becomes negatively charged. The small pieces of paper are neutral but can be polarized. Because opposite charges attract, the negatively charged balloon pulls the neutral paper bits toward it. The force you see pulling the paper pieces is called electrostatic force. This force acts at a distance without the balloon actually touching the paper. The effect works best in dry conditions because moisture in the air can allow charges to leak away quickly, reducing the static effect. Expected observations. The paper pieces will jump up and stick to the balloon as surface or follow the balloon when it moves nearby. The strength of attraction will decrease over time unless you recharge the balloon by rubbing it again. Different materials may cause the balloon to hold charge better or worse. For example, rubbing on wool might generate more static charge than rubbing on cotton. Conclusion: this simple experiment shows how static electricity works and how friction can generate electric charges on objects. The balloon becomes charged with static electricity and attracts neutral paper pieces due to electrostatic forces. Static electricity is a fascinating natural phenomenon and is the basis for many important applications in everyday life, such as photocopiers, air purifiers, and even lightning and thunderstorms. By understanding these basic principles, we gain insight into the invisible forces that surround us and influence the behavior of materials around us every day. End of experiment.